If you look up into the night sky, especially during the summer, your eyes are probably drawn to the brilliant stars of the summer triangle. But tonight, our focus is on what lies within that triangle, a patch of darkness, a region that seems almost empty. This is the constellation Vulpecula, the little fox, and it serves as a powerful testament to the fact that the most scientifically significant discoveries often come from the places we least expect.
So, this really is the central question for our discussion, isn't it? Vulpecula has no particularly bright stars, no dazzling centerpiece visible to the naked eye, and yet this cosmic underdog has been the stage for some of the most revolutionary discoveries in modern astrophysics. It forces us to ask what else is lurking in the quiet corners of the universe.
And this is the core thesis of our lecture. Vulpecula is the ultimate proof that in the cosmos, spectacle and significance are two very different things. Its importance isn't measured in luminosity, but in the fundamental truths it has revealed about the nature of matter, space, and time. So here is the structure for our analysis. We'll begin by establishing Vulpecula's position on the celestial sphere. Then we will delve into the epochal discovery of pulsars that took place within its boundaries. From there, we'll survey its other deep space treasures, examine its surprisingly modern history, and conclude with a practical guide for observing it yourself. All right, let's begin with our first section. Before we can appreciate its significance, we must first understand where to find this unassuming territory in the vastness of the night sky. The official area of the constellation is 268.2 square degrees. Now, as a standalone number, that's fairly abstract. It doesn't really give you a sense of scale, does it? So, to properly understand it, we need some context. And here's that context. Out of the 88 modern constellations, Vulpecula ranks 57th by area. So, it's firmly in the smaller half. It's certainly not a behemoth like Hydra, nor is it tiny like Crux, the Southern Cross. You could call it a modest patch of celestial real estate.
Now, despite its faintness, its location makes it quite accessible. The best time to view it is during the peak summer months in the northern hemisphere. And thanks to its position, it's visible to the vast majority of the world's population. Your primary landmark is the summer triangle itself. Vulpecula is nestled right inside, just south of the Great Swan, Cygnus.
Now we transition from where Vulpecula is to why it holds such a revered place in the annals of science. Because it was here, in this quiet patch of sky, that a discovery occurred that fundamentally altered our understanding of stellar evolution and the universe itself. Our story starts in 1967. A graduate student, Jocelyn, using a new radio telescope, detected a signal of almost impossible regularity, a pulse every 1.33 seconds. It was so precise the team half-jokingly labeled it LGM-1 for Little Green Men. Of course, it wasn't aliens, it was the first pulsar ever detected. And Vulpecula wasn't done. Decades later, in 2011, it yielded a millisecond pulsar, an object spinning hundreds of times a second, which has become a crucial natural laboratory for testing the limits of Einstein's general relativity.
So what is a pulsar? Well, the reality is arguably stranger than any science fiction. It's a neutron star, the collapsed core of a massive star that is spinning rapidly and is highly magnetized. This combination creates powerful beams of electromagnetic radiation that shoot out from its magnetic poles. As the star rotates, these beams sweep through space, much like the beam of a lighthouse. If that beam happens to sweep across Earth, our radio telescopes detect a periodic pulse.
And I cannot overstate the importance of this. The discovery of that first pulsar wasn't just finding a new cosmic novelty. It was the first concrete, empirical evidence that neutron stars, objects that had been theorized for decades but never observed, actually existed. It was a beautiful, triumphant moment where theoretical physics and observational astronomy converged.
This, of course, leads to the next logical question. What exactly is a neutron star? To grasp this, you have to venture into the realm of truly extreme physics.
This comparison truly says it all. Picture our sun, a colossal ball of plasma 1.4 million kilometers across. Now imagine taking every single particle of that sun and crushing it under unimaginable gravity until it fits into a sphere roughly the size of a city, just 20 kilometers in diameter. The density is so absurd that a single teaspoon of neutron star material would weigh billions of tons. That is the nature of the object that was first discovered in Vulpecula.
Astonishingly, the story doesn't end with pulsars.
That discovery alone would have cemented Vulpecula's place in history, but this constellation is also home to a gallery of other fascinating deep sky objects.
First, we have Messier 27, the Dumbbell Nebula. This object is historically significant as the very first planetary nebula ever discovered. Now, the name is a misnomer. It has nothing to do with the formation of planets. Rather, it is a look into the future of our own sun. You are witnessing the end of a star's life. After exhausting its nuclear fuel, it has shed its outer layers, which are now expanding into space. At the center, the hot, dense remnant core, a white dwarf, irradiates that gas, causing it to glow. Next, we have a delightful cosmic coincidence, the coat hanger. This is not a true star cluster. The stars you see are not gravitationally bound. In fact, they are at vastly different distances from us. It is purely a line-of-sight illusion, a chance alignment where, from our specific vantage point in the galaxy, these unrelated stars form a familiar and charming shape.
Vulpecula is also home to one of the most intensely studied and most terrifying exoplanets, HD 189733b. It's a hot Jupiter that presents as a beautiful, serene, deep cobalt blue world. But this is not the blue of a welcoming ocean. It is the color produced by an atmosphere laden with silicate particles. The weather here is extreme. We're talking wind speeds approaching 9,000 kilometers per hour, creating a horizontal rain of molten glass, a truly alien world. So, we've explored the astrophysics. Let us now shift our focus to the human element, the history. How did this scientifically rich region of the sky receive its peculiar name?
Unlike the ancient constellations of antiquity, Vulpecula is a modern creation. It was formally charted in 1690 by the Polish astronomer Johannes Hevelius. Interestingly, he did so shortly after a nova, or new star, flared brightly in that very area in 1670. We now know this event, CK Vulpeculae, was the result of a rare and violent collision between two white dwarf stars.
Hevelius's original name was actually longer, Vulpecula cum Ansere, which translates to the little fox with the goose. He very deliberately placed this fox in a celestial neighborhood already occupied by other predators, Aquila the eagle and Lyra, which was sometimes associated with a vulture. His rationale was that a cunning fox fit right in among these creatures.
Over the decades, as star charts were simplified, the goose was officially dropped from the name, leaving us with just Vulpecula. However, a wonderful piece of this history remains. The brightest star in the constellation, Alpha Vulpecula, still bears the official proper name Ansere, the Latin word for goose.
And that brings us to our final section. After learning of these wonders, it's only natural to want to see them for yourself. So, how do you go about observing these hidden treasures?
Well, the process is quite straightforward. First, you must locate the summer triangle. Vulpecula is found within that shape, along the line between Vega and Altair, but closer to Cygnus. With just a pair of binoculars, you can easily sweep the area and find the distinctive shape of the coat hanger asterism. To see the Dumbbell Nebula, you will need a small telescope, but resolving that faint, ghostly cloud of gas for yourself is an incredibly rewarding experience.
In conclusion, Vulpecula provides us with a critical lesson in scientific humility and curiosity. It proves that the universe's most profound secrets are not always found in the brightest, most obvious places. It challenges us to look deeper, into the dark and quiet regions of the sky. And as our instruments become ever more sensitive, it leaves us with an exhilarating final question. What other paradigm-shifting discoveries are lying in wait, hidden behind the dimmest of facades?